and welcome back. So today we have Pepe from Spain working from Grafana, and he'll be attending this presentation and talk about P6 and making a workshop for us. So Pepe, the stage is yours. Uh, be and shine this day.
Okay, thank you, Ederson. Thank you for the intro. I'm gonna start the presentation, sharing my screen. Thank you, everyone, for joining today, and good morning. Seems I am sharing my screen now. So the workshop or presentation is about load testing and performance testing using KSIG. KSIG is the tool I have been working the last years. Just a short intro about me. I joined the team as an engineer building the product, and I have recently moved to a more educational role, helping documentation, explain how to use the tool, and talking about all things about performance testing, this practice. So the topic covered these three main topics. First, an intro about this practice, not too much in details, but to explain based on some testing background, what is load testing or their difference, an overview about the tool that I'm going to be presenting, K6, why we build the tool, and what is the future direction, and then to make it more fun, a demo. I will go through different examples using a demo environment. The title of the presentation is a workshop. I would have loved to, to run the workshop together with the different participants, but with this format was not possible. The good thing is that you can run the same workshop that I am going to be doing today at home, your office, with your college. Here are the two links that I am going to be based this presentation. Let's show briefly. We have here a 2-3 hour workshop touching most of the topic that I am going to be presenting today. So just follow the workshop. It will ask you some questions so that you try to implement your own test. And as I say, it includes topics in this presentation and yeah, even more. Same for our demo environment. Let's see first our simple demo environment. Quick pizza. This is a very simple website. You can order pizza recommendation, and that's it. The good thing about this project, it have different setup and even has also more example. If you go over the KSIG folder, we are going to be running some of the sample on this foundation folder, a few of these. As I say, I hope that I pick the curiosity and you can also try on your own. Let's get started with the intro. What is load testing? If we go to Wikipedia, the description say that it's the process of putting demand or load in a system and measuring its response. As a developer, I like to see other type of testing. We have all done some type of testing, unit testing, integration testing, and it's gonna work on the same way. We are gonna verify different conditions in our system, and the difference is just the other word, load. We are gonna be testing under load, and we have commonly two ways to set the load. We could set the load in terms of users. Imagine that someone say, we are going to be launching this website and we are expecting 5,000 concurrent users during the launch. Then you will create a load test and set the load in terms of this virtual user number. On the other side, we have setting the load in terms of requests per second or throughput. That is more common, for example, if we are monitoring some of our service and we have identified that some API is starting to fail or perform badly whenever it reaches a particular traffic. Normally, our monitoring solution or observability solution will provide this traffic information in terms of requests per second. Then if we are thinking like that, we may want to set the load of our test in terms of requests per second. The other thing that it will change with other type of testing that we are more used to is what we say that is a pass or a fail, our pass-fail criteria. We are used to define too many assertions, any number of assertions, and if one fail, my test will fail. But when we design our production system, we are not looking for 100% reliability, and we are normally accepting a percentage of failures. So for example, if we measure things, we are going to be measuring in terms of a percentile, 95% of my requests, 99% of my requests. Or when we define our SLO, we are setting a particular error budget. So we will have these things in consideration whenever we set the pass-fail criteria in our load test. We will see later on. This is a simple basic test. You write your test in JavaScript. That is probably familiar to many of us. So we are doing a post, another post to a login. And the load, we could express the load like here in terms of virtual users running for 2 minutes. Let's see 4 basic concepts about how the tool works, K6. We have already seen view, virtual users. We have talked about duration. Duration means my test will be running for 1 minute. We have here the S scenario. The S scenario is the user flow or the thing that we are going to be testing. We are going to put there our test logic. So we have a scenario, view, duration, and the other concept is iterations. Iterations in K6 is just one execution of my S scenario. That means if we tell K6 to run 200 iterations, it will run 200 times the S scenario function. With this parameter, we will set different way to set the load. Just to get an overview, this is how K6 will work. K6 will schedule views that will be continuously running our S scenario until our condition does not hold true anymore. It could be until my test has run for 1 minute, or in the other case, until it has run 200 iterations. Let's see one example with Quick Pizza. We have already seen Quick Pizza. Okay, where is localhost 333? Quick Pizza is running here. We are going to be testing the backend, so we are going to see what is the request that we are doing with the backend, and we see here that we are doing a post to the pizza endpoint with some payload, and then it's return a response. So our first test gonna do basically that one. Here we have our first test. This is the Quick Pizza project. We go to the K6 folder, foundations, and here we have the number 1 test. In our test, we import some K6 modules, and it's pretty simple. We have options. We have already see that one, view, durations. We just do the post here to API Pizza. We pass the header. We pass some data restrictions. We check that the response is 200, and we log the response, and we pause the view execution for 1 second. Let's see, let's run now the test. KC is a CLI tool. It's released as a binary, and you can just download the binary or use some of the different package management solutions. The command to run our test is basic run. We give the name of the test, and that's all. So now basic started running. All the view has been executed and logging the response. And at the end of the test, it displays the results of our test. For example, this was the status of this assertion and some information, some metric information. Here, for example, we have the latency. Here we have the number of failure requests, the percentage. We will see this later on. And then it gives me more information about the test. 5 virtual users running for 5 seconds. That was a very basic test. So the different example, we will be just adding a little more information to this test. Since to consider when we are planning our testing, we cannot expect that our system will perform the same with maybe 10 users or 10,000 users. That is why we commonly define different type of load test depending on the traffic. The most common one is the load test, or what we call the average load test. We create a load test that simulates the average traffic. But it may be moment in the day that our system receives much more traffic. It could be maybe during the morning when everyone connects to our application, and it may have 10 times more traffic than our average traffic. So we may have in one side the average traffic and on the other the peak traffic or stress traffic. Other common case is a spike of traffic, something that goes very quickly from very low traffic to high traffic. It is commonly expected when we launch some marketing campaign, but it happens also more often than people usually expect. We then have the SOAK or long duration test. We may be running a test for hours, 2 hours, 4 hours, and see how our system responds on those conditions. Or to define a test to find the limits of our system. We increase the load until a moment that we know that our system will fail. And we want to identify exactly what is the breaking point. And at that moment, we may stop the test. As you can see here, we are defining the what we call ramping load. So we start from some virtual user to another, then we have some stable load, and then we ramp down our load. Let's see this example in KSIG. You will use the stages option here. We are telling KSIG run 2 seconds from 0 to 5. 5 virtual user is the target. Then stay with 5 virtual user for 3 seconds and then 2 seconds. You could define as many stages as you want. Normally, we recommend something simple. You ramp up, then you stay stable for a time, and then you ramp down. Because if you start doing like very crazy ramping scene, then it's gonna be hard to interpret the results. Let's see just this second test. We run on the same way. Number 2, stages. And the difference is just that it's gonna be running for 7 seconds, 3 stages. We won't see big difference because it's very similar load. So we see here number of iterations is higher than before, and we got again the same type of information about our test options. Then on the other side, what we are going to be measuring, and this depends on what you really want to measure. The most common case is the latency, or how it performs, how fast our system responds. This is why performance and load testing are also very related. But it could be, for example, the availability of my system. We may want to run tests much more frequently in very short periods to see if our system is up, like synthetic monitoring or synthetic testing. Common the reliability of our system, normally given by the error rate, but it could be any reliability metric in your product or your SLO's definitions. Then resilience, we may want to fail our test or even to mix with some chaos engineering practice and to evaluate how our system performs when it's recovering from a failure. Other common cases, testing the scalability policies. We may have defined some scalability policies in our system, and we want to see how system performs whenever it's scaling up or scaling down the resources. That was the intro. Let's go with some of the reasons why we build KSIG or the principle of the tool. There is 4 principles that I wanted to share with you. The first one, I don't know if you have done load testing before, but one of the most popular tools has been Gmeter, being a tool that has been created 20 years ago, and it's a GUI-oriented tool. So when we launched, we as a developer wanted to write our load test as code, because as any other testing suite, we are going to see how our testing suite will grow over time, and we want to modularize our code. Something that is going to be very common when we do load testing is the reusability of our test. For example, we may want to run the same test or the same test scenario with different load against different environment, like you can see here. And maybe I have a goal for every different environment. Maybe on the pre-release, I want to check the SLOs, and in production, I am just focusing on checking if the performance has changed, and I don't need to run with a very large load test. At the end, we are going to be starting to modularize our test. This is very common pattern. You create a load test that picks some scenario with some load options, and you are going to have some common test code between different scenarios. For example, the logging logic accessing my site. The second principle was that we wanted to build, we build an open source tool, and we also have a commercial service, cloud. We wanted that independently of the choices that you choose to run your test, there is 3 common choices. You could run the same test without any friction. There is 3 ways to run KSIG test. We have seen the first one, what we call local test. KSIG will run in one single instance, but you may want to scale your test, and that you need to distribute your test across different machines. So you could do that with a Kubernetes cluster. There is a K6 operator. You pick the same script and you distribute the load across different pods, or you can just scale your test in our cloud. So we wanted that, as I say, you choose the option that you want, and you don't need to change your script. That sometimes adds some complexity in our side when we are creating new API, because it's not the same some API to work on a single instance that working across different machines, for example. But it was one of the principles that we brought from the beginning. Then, as you have seen, you write your test in JavaScript, but the tool or the magic is writing in Golang for performance reasons. We wanted you to be able to generate a decent amount of load with a single machine, so that you don't need to distribute the load across different machines, which is sometimes a little more complex. The thing to be aware here is that KSIG does not run on Node.js, and even KSIG can reuse, import JavaScript library. It cannot use JavaScript library that rely on Node.js, because KSIG does not run on Node.js. And the last thing I wanted to share about the KSIG is the extensibility. We built the tool 5 years ago, and I think quickly the community liked the principle of the tool and started to request new capability. Like, for example, we see here 3 very common cases. I want to store the test results in this backend, or I want to use KSIG for browser testing, for failure injection testing, or I want to do a performance test to my database or to Prometheus or to one particular backend. So we realized that we won't be able to provide everything, and we needed to provide a plugin architecture. We call extensions in KSIG, and extension in KSIG allow you to extend the capabilities of KSIG. There is many extensions from Grafana Labs and also from the community. You can see here. How extensions work. Let me show you one example. Here we have the SQL extension, and an extension will make some method available in JavaScript, as we can see here, as any other JavaScript API. But extensions are writing in Go for performance reasons. So for any Go method following our convention, you will have a JavaScript wrapper. So whenever you call your JavaScript function, it will be converted to a Golang code and return the response. As a user, you don't need Go. As an extension developer, yes. The good thing is that you can import any Go library that you may know. Extensibility, at the end, the new options allows us also to test our system in new ways. Traditionally, we had been used to test our system when we had been doing performance testing end-to-end from public endpoint to covering different part of my system. But now, because we could use new protocol, for example, we could be focused on particular component. I may want to focus just on this storage system, and I have defined a scalability policy, and I just want to, for example, test this particular component or cluster. Or we could be focused on some integration test. I know that it's the queue system that is starting to perform badly when we have put too many things of our queue. Maybe I just focus on these 2 or 3 components, and it's gonna just facilitate me the testing. So I don't need to go for a end-to-end test just to really verify some internal part of our system. Let's go with the basic. I will go through to show now different basic features and go with different examples. The first thing that I wanted to show are basic options, and we have already seen that. There is many different options you could find here. Some are options at the test level, some are specific for particular APIs. And what I wanted to show here is that you could set the option on the script, or you could also override using some environment variable or via CLI flags. Let's see the previous example. We have, for example, a stage. We are going to tell just run now this test with one iteration. And this iteration option has overwriting my stages options. As we can see here, it has run only one iteration here. KSIG has also a setup and teardown function, which is familiar to many testing frameworks. The setup function, if defined, will be executed before our load test start, and is commonly used to interact with our testing environment or to fetch data that we want to use in our load test. At the end of the test, if it is present, KSIG will execute the teardown function. Let's see the number 3 lifecycle example. We have now added the setup function. We just check that the system responds. If not, it throw an exception to not execute our load test. And on the teardown function, we just add a new log message. We run this test, and Okay, it passed this check that Quick Pizza returned at 200 spawn, and it had executed the test. Whenever it had finished, it logged the response, the message that we added on the teardown function. That's it. The third one, metrics. We have already seen some of the metrics. The first thing that is important to know is that KSIG provides two types of metric, what we call the built-in metric that KSIG automatically collects depending on the KSIG API that you will use. Let's see some of those. For example, information about the checks, information about the data sent or data received, iterations information, view information. If you use the HTTP module, you will get information about the connection, the latency, percentage of failing requests. There is different modules. So if you use this module like the browser module, it will collect browser metrics. If you use the WebSocket module, it will collect WebSocket metrics. Same with gRPC. Also, one extension could also collect built-in metric, and then it will be automatically presented. Then you can also define your custom metric to measure anything that you want in your scenario code. It may be important to know that in case there is 4 types of metrics, and depending on what you want to measure, so learn those and then pick the one that you may need. A trend metric just collect the different data points. Like for example, here, HTTP rec duration is the latency, and it's gonna be collecting all the requests, all the latency for all the requests. At the end of the test, it presents the different statistics. A rate metric, for example, HTTP rec fail, it gives me a percentage of success or error, and it gives me also the number. A counter is just counting what we add in the metric. For example, here, this one, HTTP recs, is counting the number of requests. And last, we have a gauge that provides just the last result stored in the metric. Let's see another example. We go to number 4, metrics, and we have added the metric class we are importing here for a trend metric and a counter metric. Then we instantiate the metric outside of our scenario function. We have a counter to count the number of pizza that is respond. We have one that it will track the number of ingredients of the pizza. So we just instantiate, and then it will be shared by all the views that will be executed. It adds a new pizza. Whenever it got a response, it stores the ingredients. Let's see the example. Number 4, metrics. The only difference is that at the end of the test, it will display the metrics information. And here it is. Quick pizza ingredient, the trend, provide the statistics, number of pizza, 26, 1 pizza for each iteration, same number of iterations. Assertions in KSIG, we have already seen checks. They are just like common assertions. We add just a condition, and it will track if it was true or false with a name. The important thing to know is that checks by default don't fail our test. That's it different, as I said at the beginning, with other type of testing. Why? Because imagine that you have 1 million of iteration or 10 million of iteration, a large load test, or even 10,000 of iteration, a smaller load test. Because one check fail, I may have 20 checks in my test, checking different things. Because one check failed, that does not mean that my system is failing. As I said at the beginning, we are accepting or expecting a small percentage of error, and that's normal. If we want to define our pass-fail criteria in our test, we will use thresholds. Thresholds are defined based on the metric. Let's see the example. We define thresholds on the options, and we tell KSIG to check a particular metric information. Like here, we are telling I am expecting the rate should be, I am expecting the failure rate should be below 10%. In this other threshold, we are telling KSIG the latency, 95% of the latency should be below half a second, 99% of the latency should be below half 1 second. Here, let me check this one. We can also we can also set a threshold based on a custom metric, quick pizza ingredient, and we are telling KSIG the average should be below 8. Abort on fail, abort if whenever checking this condition, the threshold has not been met. Let's see one example. KSIG number 5, yes. Now we are running the test. We have already set the threshold. The difference will be, as we will see, the check mark that we have see here on the information. So this threshold passed, this threshold passed, this other threshold passed. We have here our test has passed. KSIG now return, or it has already returned before, a 0 error code telling to the tool that it has the test has passed. If we change a threshold like this one, we are going to see how our test will fail. Let's run again the test. And now it has quickly failed because we told KSIG abort on failure. It had checked that the average is not below 2. That was, let's see, that was our setting. Average should be below 2. Average was 6. Then here the threshold fails and KSIG return now non-zero error code 99. That will allow you to integrate KSIG in your CI/CD jobs or pipelines. What about thresholds? Different ways to set the load in KSIG. We have already seen the constant view, like view and duration. We have seen ramping. We initially saw the iteration. We can tell KSIG a fixed number of iterations in total or per view. And the last way to set the load in KSIG was it's called arrival rate executors. And arrival rate executors allow to set the load in terms of iterations per second in KSIG. And that is a little tricky. Let's go through another example. I am jumping now to example number 8. And let me show with the example. In KSIG, we tell, okay, KSIG runs 20 on a rate of 20 per time unit, normally per second, 20 iterations per second. This is the type of executor or scenario that you will use if you want to set the load in terms of requests per second. In KSIG, you cannot specify a request per second, the load in terms of requests per second, because KSIG doesn't know in advance how many requests your test will execute. It could be that you run 2 requests, 3 requests, 4 requests, or even you have defined many requests in your load test. Some of them could be executed or not. So KSIG doesn't know in advance how many requests your test will do, but KSIG knows how many iterations will be running, and it could scale up or down the number of running iterations. So you will set the load in terms of iteration per second, and if you know how many requests will be done, with that way you are going to know exactly how to set the load in terms of requests per second. Let's see this example. For example, we want to reach 20 requests per second in our load test. I am going to define 20 iterations per second, and I am going to just do one request in our test. This is what we did in this case. We set 20 iterations per second, and I make sure that we just do one request in our load test, and we don't tell KSIG to pause between executions. Let's see this example, number 8. We see at the bottom that 20 iterations are running per second. So KSIG is scaling up the number of views to reach this goal. And here at the end of the test, we have the information about the iterations. 201 were executed, and the rate of iteration was almost the 20 goal that we have. If we go to the request, we have executed 202 requests with almost these 20 iterations per second. So if you need to define the load in terms of requests per second, you will use the arrival rate executor. Also, to comment, you could define multiple S scenarios in your load test, and 1, 2, as many as you want. Each S scenario could be configured with different load pattern. Like some users are doing this action in my site, these other users are doing other, are interacting differently with my website. So that gives much more flexibility, the way that we want to set up our performances. Yeah, wrapping up, I think those are the two last topics. So script recorder and test results. A script recorder are a common thing when you are doing some load testing. So a script recorder will facilitate you to auto-generate a test. Imagine that you have a test that you don't know exactly how it works. A system that you don't know exactly how it works, and you don't know how many requests have been done. So what you could do is, as a user, you could record yourself interacting with the service. I go to this page, I navigate, I do this action, and then from there we are recording your session. Like, for example, there is two different ways in KSIG. You could use a browser extension, or you could record yourself with a proxy. Then on the proxy case, you are interact with your site. The proxy will record all your requests. It will be converted to a HAR file, which is a format that tracks all the requests done with a system. And then from this HAR file, you are going to convert a KSIG test. With the browser session, the process is the same. So you just you start recording here, then you interact with you are now recording, you will interact with your website, you will do as many different steps as you want. And then at the end of the test, it will auto-generate a KSIG script for you. Other common case, for example, is to use the Chrome Inspector tool, that it could also convert all the requests in a HAR file. So at this stage, we have some generated KSIG script that it will fail because probably you are using a particular a particular session ID, for example, or some data, because it's going to just provide this hard-coded information. What you are going to need to do is to pre-process this script. You may have a script with many, many different requests. It has facilitated this job. And now you need to do what we call the correlation. For example, correlation between requests. I pick up some information from one request, I pass to a variable, and then I pass to the other request. So you find those variables that are reused with all the different requests. And also you could parameterize the data for each view so that each view, for example, use different information. Like I am user 1 and I want to use this credential, user 2 will use another credential, and so on. So after editing your test, fixing this situation, you will convert the auto-generated test in a proper functional load test. And the last topics are results. I will go briefly. We have already seen on the terminal information, KSIG also by default has the option to visualize the results with web interface. Let's see this example. Let me copy the command that is, it's required. Some more changes here we have. So we are telling KSIG to enable the web dashboard. And okay, now I am passing the duration of 30 seconds to get more data. We run the number test and it's telling me the web dashboard is available and running on my local host. It's already here and we can see. Now we don't see only the summary that it was shown on the terminal. We have this information here as we have in the terminal, but we can see also the different metrics during the execution of my test. And we could see maybe at the moment that something have changed. So that is the way that you normally want to visualize your performance results. But in both cases, we don't have the data. It's going to be very common that you may want, for example, to compare the result from one test to another test, because between one test and another test, you have changed something. So for that, you need to store the information of your test results somewhere that you can also compare then result 1 versus result B. Or another common case, I want to see if something have changed over time, over a longer period of time. You may want, or you may need to store the result. For that case, it also present different choices. And yeah, we wanted to, like with the extension, to provide the option that you may want and the option that it may fit better for your particular case. So we have implemented a few options. Others have been created by the community. You could create your own extension to output the KSIG results where you want. Here there is a few examples. In that case, we are going to pass the -o or dash output parameter with the name of the output. Then we could visualize with any visualization tool. Here we have, with the Quick Pizza project, also running a Prometheus instance, also a Grafana instance that will fetch this Prometheus information to visualize the KSIG result. Let me show you this example. I will copy the command. Now we are indicating KSIG to output the results to the Prometheus remote write endpoint. So this endpoint is running on the default setting. You could change the settings, and here it is. So KSIG say output, sending the results to this endpoint. Let's see the Prometheus, and let's see, and here are the KSIG metrics, for example. Duration, let's see the graph Here are the different basic metrics. Now, yes, then we can see all those metrics that we have seen before had been stored in this Prometheus instance. You probably won't use Prometheus to visualize the result. Probably you won't make to use something like Grafana that can fetch the data and visualize the result. There is some dashboard from the community. There is dashboard in Grafana for many different options. Here I am using one of the Prometheus dashboards, and it visualizes the basic results. We can see here, it allows also to select if we run different test ID, and we can see those visualizations that are, in that case, very similar. Okay, request information about my checks, information about the aggregated information. It was very similar to our dashboard. We have designed both dashboards, so we try to find this similarity. Okay, that was all for today. As I say at the beginning, I hope that you run also the website yourself. Thank you, everyone. More information in the website, and thank you.
Thank you, Pepe. Unfortunately, we don't have time for questions. Although we have a question, if you can answer in the chat. So thank you, folks, and